Okay, here we are where we left off last time. It's now time to take our training data and create batches for training purposes off of it. The way we can do this is by saying from TensorFlow .keras .preprocessing .sequence import time series and then a capital G generator. So go ahead and run that import, and then off of this, go ahead and just call help on this time series generator class so we can explore just a little bit about it. So essentially what this is, it's a super helpful utility class that generates these batches for this sequence data. So it takes in the sequence data, and what we have to be familiar with is the actual arguments or parameters that we provide this time series generator. So what it does, and the parameters that we're going to be focused on, is the data parameter, essentially what the actual x is, or the source of this x that we're training on. Then the targets is the label, again the source of the label, and in our case they're actually both going to be the same thing. We're both taking the data in our targets from the training data because we have time-stamped sequence information. So we're going to essentially be passing in data and targets as the same source. Okay. Then we have the length, which is the length of the output sequences in number of time steps. And then we have, later on, we'll see that there's a batch size. So beyond sampling rate or stride, which we don't have to worry about, really what we're going to focus on after that is batch size, which is the number of time series samples in each batch. Okay, so let's go ahead and play around with these parameters just to make sure we understand time series generator, because a lot of the work is actually going to happen behind the scenes for us. So I'm going to create a couple of variables here. One is length, and this is the length of the output sequences in number of time steps. So we'll say 2, and then the batch size is essentially how many batches are we returning, or how many time series samples are we returning in each batch. So we'll go ahead and say 1. And typically, when it comes to sequence information of time series, just the batch size of 1 performs pretty well. So now it's time to actually create our generator. So we'll say time series generator, and then we have to decide what is the source of our data. Essentially, what contains the X timestamp or the X index. And in our case, it's our scaled training data. And then the next one is asking us, well, where is the Y label contained? And for our case, that's also scaled training data. And it makes sense because the scaled training data has both series of information. And if we take a look at it, it's right here. The scaled training data that we saw, in this case it's the test, but it's the same sort of format. It already has the source of the index, or X, and our Y, our label. Basically what we want is that the model, given some value here on the index, predicts what the value should be here. So later on, we'll be able to pass in something like 50.1 and see what the model thinks the output should be. Okay, so these happen to have the same source. Then after this, we have to decide on the length. So we'll pass in length is equal to length, and then we'll also say batch size is equal to batch size. Whoops, make sure that's correct. There we go. And what we're going to do is we're going to play around with length and batch size to make sure that you understand what these parameters actually do. So let's take a look at the length of our scaled training data. So recall our training data right now is 451. Let's take a look at the length of our generator object. Essentially, this generator object is going to yield or generate batches for us. So our generator object is 451 minus our length, 2, which kind of makes sense because what we're going to do is explore what does the first batch actually look like. So what the generator does, if we take the generator and just ask for at index 0, what does the first batch look like? Well, we're going to do some tuple unpacking here because it returns both the X and the Y that should be predicted off of the X. So this is the very first batch that is generated off of this. So if we take a look at X, it looks like this. It's 0.499 and 0.549. And if we take a look at our Y, it's 0.599. So what do those values actually mean? Well, let's take a look at our scaled training data again and see what's actually happening here. Essentially, what we're going to be telling our recurrent neural network model is, given these 2 points in a row, try to predict this third point. And you'll notice that the very first 3 numbers in our scaled training data set is 4.999, then 5.49, and then the third one is what it's going to try to predict, which is 0.599. So that's essentially what this generator is using when it comes to length. We're saying, given this length of 2, predict this 1 into the future. Let's play around with that just to make sure we understand. Let's see what happens if we say our length is equal to 4, and then redefine this generator. Notice now the generator is the length of the scaled training data minus 4, which makes sense because we can't have the generator go all the way to the end of our training data set because then it won't have those extra values into the future to actually grab from. So let's see what the actual XY generator at 0 returns now. Notice now, since the length is 4, it's going to say, okay, here are the first 4 points. Go ahead and predict point number 5. So that is what this length is representing. Now, this length shouldn't just be an arbitrary choice. The length you actually think about because it should be enough for the network to pick up on any seasonality or repeating effects. If we think back to our actual data frame, so if I plot my data frame, notice that it's a sine wave. What I want to do is make sure that I feed my network a long enough sequence of information so it can begin to pick up on any trends. It's probably not very helpful for the network to just see 1 point into the past and 1 point into the future. Instead, I probably want to at least have enough points so that a network can pick up on this cyclical motion here of the trend. So I can see that if I go from maybe 0 to probably around 25 points, I can see a full cycle. So that doesn't mean 0 to 25 on the x-axis. It means actually 25 individual points. And you can expand on this, but keep in mind, the larger the length, then the longer the training time. Okay, so imagine you were dealing with yearly time series data, and you were on a yearly sales cycle. Maybe you had holidays, sales cycle, summer, etc. You would probably want to include at least a year's worth of information in this length variable. So what we'll do is we'll go ahead and set this length to 25, and you can feel free to expand on that. But I'm going to now set length to 25 so that when I actually look at my generator, what it's doing is it's feeding 25 pieces of information as x and then asking the model to predict what point number 26 looks like. Okay, so that's our time series generator object. What we're going to do in the next lecture is actually create the model and then evaluate it. And we'll explore the differences between a simple recurrent neural network and using a long short-term memory unit. I'll see you in the next lecture.